Have you ever stared at the night sky and wondered, does the universe go on forever, or does it have an edge? This question has fascinated humanity for millennia, challenging our understanding of reality. Imagine walking a road. If it's finite, you'll reach an end. If infinite, you could walk forever. A finite universe has a specific size, a limited amount of matter and energy. An infinite universe, though, stretches endlessly, with no boundaries. Every possibility, no matter how unlikely, must happen somewhere. In such a universe, there could be another Earth, another you, reading these very words. Our own galaxy, the Milky Way, is 100,000 light-years across, and there are billions of galaxies in the observable universe. So when we ask if the universe is finite or infinite, we're grappling with a scale that defies imagination. The answer could change everything we know about existence. It's the ultimate cosmic mystery, and it's a question that pushes the limits of human curiosity. Let's explore what we know and what we don't. For most of history, people imagined the universe as a small, finite dome with Earth at its center. This comforting view was upended by Copernicus, who showed that Earth orbits the Sun. Giordano Bruno went further, suggesting the stars were distant suns, and the universe might be infinite, a radical idea that cost him his life. Galileo's telescope revealed the Milky Way was made of countless stars, shattering the old boundaries. Astronomers like Herschel tried to map the galaxy, thinking it was the whole universe, unaware of the vastness beyond. The real breakthrough came in the 1920s, when Edwin Hubble proved that faint nebulae were actually other galaxies, millions of light-years away. Even more astonishing, Hubble discovered the universe is expanding. This meant the universe had a beginning, the Big Bang, and has been growing ever since. Our view of the cosmos expanded from a small, finite bubble to a vast, dynamic universe. The question shifted. Not just how big is the universe, but what is the nature of its expansion? Each discovery pushed the boundaries of what we thought possible. And the quest continues. Asking about the universe's size means asking about its shape, the geometry of space itself. Einstein's general relativity tells us that mass and energy curve space-time, shaping the universe on the largest scales. There are three main possibilities: flat, open, or closed. A flat universe is like an endless sheet. Parallel lines never meet, and space could be infinite. Current measurements suggest our universe is very close to flat. An open universe has negative curvature, like a saddle. It too would be infinite, stretching out forever. A closed universe is like the surface of a sphere, finite but with no edge. Travel far enough in one direction, and you'd end up where you started. In a closed universe, space is limited, but you'd never find a wall or boundary. These shapes aren't just abstract, they determine whether the universe is infinite or finite. Our best data points to flatness, but the margin for error is small. The true shape of the universe is still being measured, and with it, the answer to whether the cosmos is endless or contained. The geometry of space is the key to the universe's ultimate fate, and it's a puzzle we're still piecing together. If the universe is infinite, then every possible arrangement of matter must exist somewhere. That means there could be countless copies of our solar system, our planet, even ourselves, scattered across the cosmos. This is the level 1 multiverse. No new physics required, just infinite space and finite possibilities. Our observable universe would be just one patch in an endless cosmic quilt. But what if the universe is finite? The theory of cosmic inflation suggests our universe might be a single bubble, formed in a burst of rapid expansion after the Big Bang. Eternal inflation proposes that new bubble universes are constantly forming in a larger inflating space. In this scenario, our universe is finite, but part of a much larger, possibly infinite multiverse. We'd be trapped inside our own bubble, unable to cross into others. So the question becomes, is our universe infinite, or just one of many? Either way, the implications are staggering. How do scientists investigate the universe's size and shape? We can't travel to the edge, but we can study the cosmic microwave background, the afterglow of the Big Bang. By mapping tiny temperature fluctuations in this ancient light, scientists can infer the geometry of space. The Planck satellite and other telescopes have measured these patterns with incredible precision. The results? The universe appears flat, parallel lines stay parallel, and the observable cosmos looks Euclidean. This suggests the universe is either infinite or so vast that any curvature is undetectable from our vantage point. Some data hint at a slight positive curvature, which would mean a finite universe, but the evidence isn't conclusive. What we know for sure, the universe is enormous and very close to flat. The margin of error leaves room for both possibilities. We're on the edge of discovery, but the final answer remains just out of reach. The cosmos keeps its secrets well, and we keep searching. So where does that leave us? We know the universe is expanding, began with a big bang and is nearly flat. But the difference between infinite and merely vast remains unresolved. New telescopes like the Vera Rubin Observatory and the Euclid mission will map billions of galaxies, searching for subtle clues about the universe's shape. The answer matters. A flat or open universe expands forever, growing colder and darker. A closed universe could eventually collapse in a big crunch. Our cosmic fate hangs in the balance. But beyond science, this quest is about human curiosity. We look up and wonder, what's out there? Whether we find an edge or prove there's none, the journey itself expands our minds. It connects us to the grand story of the universe. For a brief moment, we are the conscious observers of this cosmic drama. The search for the universe's edge is, ultimately, a search for our own place in the cosmos. And that journey may never truly end.